is equations with variables on both sides. First, we have definitions. Identity. Identity is an equation that is true for every value of the variable. So in other words, it would not matter what value I plugged in for that variable in a particular equation. If any number in the known world worked and made that equation equal, we would have identity. Okay? Very important concept number one. An equation has no solution if no value of the variable makes an equation true. Okay? So example, we have 2x equaling 2x plus 1. Well, 2x would equal 2x, but 2x is not going to be the same as 2x plus 1 no matter what I do. And if that is the case, then we have no solution. Okay? Steps to solve equations with variables on both sides. Just like before, our first step is always going to be to distribute. Then we are going to clear the equations of any fractions. This is optional. I do suggest that we go ahead and do it because I think it just makes things easier. Number 3, get the variable on one side and the sign and number on the other. And then last but not least, add and subtract, and then multiply and divide. So let's look at some practice problems that have variables on both sides of my equation. If I start with something like this, 6x minus 2 equals x plus 13. Okay. First step is to distribute. Well, in this particular case, I don't have any parentheses, so I don't have to worry about that step. I can move on. Then it is to combine like terms on both sides of my equal sign. So if I look at the left side of my equal sign, I don't have any like terms. If I look at the right side, I still don't have any like terms. So I move on. Third step is to get your variable on one side of the equation. Well, I'm going to go ahead and move my variable from here over to here. Okay, so I have 1x, so the way to get rid of it is just subtract 1x. What I do to one side, I must do to the other. So x minus x gives me nothing. 6x minus x gives me 5x. And then, of course, I still have my minus 2 equaling 13. And then I'm still left with a two-step equation that we've been working on. I got to get my numbers to one side, so I have to add 2 to both sides because that's the opposite of subtraction. So I end up with 5x equaling 15. And then last but certainly not least, I divide x equals 3. Number 2, again, I look to see is there anything to distribute. I do not have any parentheses, so I'm not going to distribute. So I have to get my variables to one side. Oh, sorry, I skipped a step. Got to combine like terms. There is nothing on that side to combine. There is nothing on that side to combine. So I move on. We put the variables on one side. To do this, I'm going to subtract 2x from both sides. Okay? Watch your signs. 2x minus 2x gives me nothing. But if I have minus x minus 2 more x, I'm going to minus 3x. So I have 8 minus 3x equaling a negative 1. Okay? So then I'm going to get my numbers to the other side. To do this, I'm going to subtract 8 because this is a positive 8. Subtract 8 from both sides. So I end up with minus 3x, because that has a minus sign in front of it, equals a negative 9. To do that, and then I just divide by a negative 3. So x would equal 3. Equation number 3. If you look at it, distributive property comes first. There is no distributive property in this particular equation. So we're going to go ahead and combine like terms on both sides. If I look at my left-hand side, there is nothing to combine. If I look at my right-hand side, there's nothing to combine, so I can move on. I got to get my variables to one side. Now, it doesn't matter which side I bring my variables to, okay? In this particular occasion, I decided to move it over here. So I subtracted 2n from both sides. So I'm left with a minus 5 equaling 6n plus 7. And then I decided to put my numbers over here so they'd be on the opposite side. I'm going to subtract 7 from both sides. Again, watch your signs. I have 6n equaling negative 12 because minus 5 minus 7 more gives me a negative 12. Then I divide by 6 on both sides and n would equal a negative 2. All right, example number 4. First thing I need to do is to distribute. I don't have any parentheses, so I don't have to distribute. My next step is to combine like terms. So I'm going to look at both sides of my equation. If I look at the left-hand side, 4p and 10 are not like terms, so I cannot combine them. But if I look at my right-hand side, I have p, 3p, and minus 2p. So those I can combine because 1p, 3p, and minus 2p are all like terms. So 1 plus 3 gives me 4p, and then minus 2p gives me 2p. So I end up with 4p minus 10 equaling 2p, because all I did was combine like terms on the right side of my equation. From there, I have to get my variables on one side. So again, I chose to put them over here. I subtracted 4p from both sides. If I do that, I have a minus 10 equaling a negative 2p, because 2 minus 4 is a negative 2. And then I just divide by negative 2 and end up with p equaling 5. Okay. Let's do the same thing with this equation over here. My first step is to distribute. So that's what I'm going to do. I look and I see that I have parentheses, so I must distribute into those parentheses first. Always, always, always. So that gives me 4x, and then 4 times 5 gives me 20. Okay? Then I am to combine like terms on either side. So is there anything over there to combine? There's not. I look over here. There's nothing over there that combines or that is like terms. Then I need to get my variables on one side and my numbers on the other, my coefficients on the other. So I'm going to go ahead and put my 4x's over here. So I'm going to subtract 4x from both sides. So 6 minus 4 is 2x, and it's going to equal 20. Okay. And then last but certainly not least, I divide by 2, because that's the opposite of multiplication, and then x would equal 10. And if you needed to, which you always do, if you want to know to get 100, you plug it back in. 6 times 10 is 60. And then if I look at my other side, I would have 10 plus 5, which is 15. 15 times 4 is also 60. So I know that my sides would equal and that 10 is the correct answer. Here's some practice problems. And it might be a good idea if you go ahead and pause your video so that you can go ahead and do these problems without me and then check to see if you are correct when I start talking and doing them. So that might be a good idea. First step on number 1 is to distribute. You notice here that you have distributive property on both sides. So I have to do it on both sides. Watching my signs. Okay, 2 times 4 is 8, and 2 times a minus 2 is minus 4x's. Okay, and I do it on the other side. Negative 2 times x is a negative 2x. Negative 2 times 5 is a minus 10. Okay, so that's the distributive property. I've done it to both sides. Next step is to combine like terms. If I look here, are those terms alike? They're not. I look at the other side, are those terms alike? They're not. So we can move on. Okay. I have to get my variables on one side and my numbers on the other. I'm going to choose to take these variables and put them over here. So the opposite of a minus 2 is a plus 2x. I'm going to do that to both sides. These are gone. I'm left with a negative 10 on this side. And we have 8. Negative 4x plus 2 is just minus 2x. Okay? And then I got to get my 8 over there. So let's subtract 8 from both sides, because this is a positive 8, right? So let's subtract it from both sides. We have negative 2x's equaling negative 18. And then I would divide by a negative 2. Okay, so x would equal 9. Okay? If you look at this over here, notice that these are fractions, okay? My first step is still to distribute, but if I look, I do not have anything in parentheses, so I do not need to distribute. The next step would be to combine like terms or to eliminate my fractions. If we are eliminating my fractions, if we look here, this is an easy one to eliminate fractions from. They all have 8 as a denominator. So to get rid of the 8, all I have to do is multiply the entire equation by 8. And that just gets rid of all of those. So I end up with 7w equaling 4w plus 6w. It's not always that easy, but when my denominator is all the same, you just multiply them by that number and it'll get rid of those fractions. Okay? So then let's combine like terms on either side. There's nothing on the left-hand side. But let's look at the right-hand side. I have 6w and 4w, which gives me how many w's? 10 w's. Okay? So this immediately looks very strange, doesn't it? It's not possible for 7 times one number and 10 times the same number to be equal, isn't it? That's not fair, because if I just say I picked a number for w and said 2, 7 times 2 would be 14, but 10 times 2 would be 20, and that's not equal. Because the two sides of this equation do not equal, we are going to say that there is no solution. Okay, because that is obvious that those two cannot possibly be equal. All right, let's look at the bottom here. We have 0 equaling some decimals. We're going to treat the decimals just like we would treat anything else, okay, like our whole numbers. So first step is to distribute. I don't have anything to distribute. Second step is to combine like terms. So I have b, b, and b, okay? So I have 0.98 plus 0.02 minus 1 gives me 0b. Okay? If I were to look at that, anything times 0 is always 0. So this would be 0 equals 0. Is that a true statement? Well, yes, it is. But it also means that I don't have any variables left. Okay, and if I don't have any variables left and the numbers equal, 0 equals 0, this is going to be one that is called identity. Okay, or you could say all solutions. Okay, because it doesn't matter what number I would plug in for b, all numbers in the real number system would make this equation equal to each other. Okay, 4. Again, I have no distributive property, okay, so I'm going to combine like terms. Is there anything alike on the left-hand side? There is not, because this is a y and this is just a plain 2. On the right-hand side, I have 0.8 minus 0.3y is 0.5y. Okay, and I have 0.5y plus 2 equals 0.5y. Well, I could go ahead and subtract 2 from both sides. It would just move it over here. 0.5y would equal 0.5y. But it's not possible for 0.5y, or half of y, to equal half of y plus 2. That's just not a possibility. So this one would also be no solution.